Okay, for this last lesson, we're going to take a look at some problem solving involving quadratic equations. So, for the first example, the height in h meters of a projectile above the ground at a time t seconds after its launch is given by this quadratic. H as a function of t is equal to negative 4.9 t squared plus 16t plus 2. First, it wants us to write a quadratic equation which could be solved to determine the time it takes for the projectile to hit the ground. Well, when it hits the ground, the height is going to be 0, which means that I can use the equation 0 is equal to negative 4.9 t squared plus 16t plus 2. If I'm algebraically determining to the nearest tenth of a second the time it takes for the projectile to hit the ground, then I'm going to say that, using my quadratic formula, t is equal to negative of, my b value is 16, plus or minus the square root of 16 squared minus 4 times negative 4.9 times 2, all divided by 2 times negative 4.9. This is going to give me negative 16 plus or minus the square root of 295.2, all divided by negative 9.8. Now, there's two possibilities here. Either I can take the plus t is equal to negative 16 plus the square root of 295.2 over negative 9.8, and that's going to give me a value of negative 0.1. Well, that doesn't make sense because I'm not going to travel back in time for this to happen. The other possibility is if I have negative 16 minus the square root of 295.2, all divided by negative 9.8, and this should give me 3.4, which means that it takes 3.4 seconds for the projectile to hit the ground. For the second example, a special enlarger bulb is designed to enlarge photographs from a 4x5 enlarger so that the reflector takes the shape of a parabola if viewed from its side. The depth of the reflector is 2 centimeters. When placed on a coordinate axis, the equation for the parabolic reflector is right here. Y is equal to negative 2 over 9x squared plus 4 over 3x. When it wants us to write a quadratic equation, which could be used to solve to determine the diameter, well, if this is at the point of 0, 0, then I want the other x-intercept. I want the value of x and 0 over here. So I'm going to replace my y value with 0 in order to solve this. Is equal to negative 2 over 9 x squared plus 4 over 3 x. If I only want to have integer values, I'm going to multiply all three terms, the 0, the negative 2 over 9x squared, and the positive 4 over 3x, all by 9. So 0 is going to equal negative 2x squared plus 12x. If I'm determining the diameter of the reflector bulb by factoring, I'm going to say 0 is equal to, I'm going to divide the negative 2 and the x from both parts here, and I'm going to be left with x minus 6. Well, if negative 2x is equal to 0, dividing by negative 2, x will still equal 0. This was my starting point of 0, 0. So this isn't going to be my answer. The other possibility is if x minus 6 is equal to 0, x is going to equal 6. And this does make sense. Which means that the diameter is 6. In this case, it's in centimeters. If I'm modeling a situation with a quadratic equation, the first thing is I introduce a variable to represent an unknown value. Sometimes I'll tell you what the variable is going to be. More often than not, the variable is x. I need to form a quadratic equation from the given information, which means that it should have an x squared. Otherwise, it's just going to be a linear equation, and I've done something wrong. Then I'm going to solve it using either graphing, factoring, or the quadratic formula, and then state the solution to the problem. So, the paved walkway from the main school building to the phys ed block at the school is L-shaped, with the total distance being 230 meters. A student taking a shortcut diagonally across the grass shortens the distance to 170 meters. So, if I'm drawing a sketch to illustrate this, well, I'm going from one spot to the next spot, doing a perfect L shape here. And the total distance for both these sides is 230 meters. If the person is cutting across the grass at a diagonal, that is 170 meters. And I've created this right angle triangle. If one of the side lengths here is x, the other side length is that total 230 minus the x. And so now I have three sides of a right angle triangle. If my Pythagorean theorem is a squared plus b squared is equal to c squared, then in this case, I'm going to say that's going to be one side, or one of the legs is x, and I'm going to square it. The other leg is 230 minus x, and I'm going to square that. And the hypotenuse is 170, and I'm going to square that. Which means that x squared plus 52,900 minus 230x minus 230x plus x squared is going to equal 170 squared is 28,900. When I move everything to the left-hand side and combine the like terms, I get 2x squared minus 460x plus 24,000 is equal to 0. I can divide all of these terms by 2. There's a common factor of 2 with all these. And I want to make the numbers as small as possible. So at this point, I'm going to say that x squared minus 230x plus 12,000 is equal to 0. I could use my quadratic formula and state that x is going to equal the negative of negative 230 plus or minus the square root of 230 squared, negative 230 squared, minus 4 times 1 times 12,000, all divided by 2 times 1, and I can simplify this. Or I can factor it. Two factors of 12,000 that add up to negative 230 are going to be negative 150 and negative 80. Which means that in this case, if x minus 150 is equal to 0, x is equal to 150. If x minus 80 is equal to 0, x would equal 80. These are the two possibilities for the side lengths, so one leg is 150 meters and the other is 80 meters. They both combine to make that 230 meters.